In this video, we're going to talk about some ideas called inverse trig or inverse trigonometry and solving triangles. And we're going to talk about that. In class, I told you would need some extra notebook paper because the only part of the note packet we're going to use is this bottom portion here. But before we get started on this, I want you to have out that blank sheet of notebook paper. And we are going to talk a little bit about what inverse means in mathematics. When we talk about inverse operations, we are referring to operations that would cancel each other out and leave the result with what you started with. Okay, the word inverse kind of means opposite here. So like if I started with an x value and I added 2, the inverse operation would be to subtract 2. And that would leave me with just this x value. Same thing if I started with subtracting 2, the inverse operation would be to add 2. Leaving me with just the x. Okay? Same thing for multiplying and dividing. If I took x and I multiplied by 2, the inverse operation would be to divide by 2, because that leaves me with just x. Or if I started with dividing by 2, I would multiply by 2 so that I get a result of just x. Okay, and then we even go back and talking about when I take an x to a power, like if I take x and I square it, the inverse operation of that is to take the square root, because that leaves you again with just x. Same thing if I started off with the square root of x. If I start with the square root of x, the inverse operation of square root is to square it, because that cancels it out and it gives me just x. So that's what inverse operations are. They're operations that cancel each other out. Well, these trigonometric ratios can be thought of as trigonometric operations or trigonometric functions. So if I start with sine, cosine, and tangent, okay, let's say I had sine of some angle A. I'm not even going to draw the triangle. I'm just using sine of A equals the opposite leg over hypotenuse, remember from our SOHCAHTOA. Then this too would have an inverse operation to cancel out this sine and leave you with just a at the end. And so I'm going to show you what that is. If I thought of this as an equation, whatever I do to this side, I have to do to the other side. So to do the inverse operation of sine, we actually call it the inverse sine. And rather than writing out inverse sine, we actually use a symbol for that. We still write sine, but then we do a little -1 power. That is not actually using any kind of exponent. We are just using that to represent the inverse sine of this side of that equation, because that cancels out sine. Inverse sine cancels out sine. But I have to do the same operation to the other side of my equation. So I have to do the inverse sine of this side of the equation also, which is opposite over hypotenuse. Okay? So what that does is if it cancels out the sine part of this, I'm left just with the angle measure for A equaling whatever the inverse sine of opposite over hypotenuse is. And the same would work if I was dealing with cosine or tangent. It would just change what this ratio is. And so what that does is it allows you to use inverse trigonometry, and I'm going to explain where you find this on your calculator. This is just a function of the calculator. There's nothing new you have to do on paper other than just redoing it a little bit. But I'm going to show you an example that uses this concept. Okay? If I did the sine ratio of a, let's just choose an angle measure. Let's choose 72 degrees. Okay, I just have to choose an angle measure less than 90 because these have to be acute angles. If I did that and I just plugged that into my calculator like we talked about last time, it would look a little like this. Okay, remember we can just type that into the calculator and we'll get a decimal value. So I'm going to hit sine And then I'm going to type in my 72. If you hit equals now or enter, that would give you the answer. I like to close the parentheses. It really doesn't make a huge difference. But that gives us about 0.951, and if I rounded to that next place, it'd be a 1. Okay? And we like to write some of these out to the 4th decimal place. But what this tells me then, if I were to do the inverse sign of that ratio, remember this decimal represents a ratio, that means I would get 72 degrees. Okay? And so I'm going to type in my inverse sign. Now, here's how you find that on the calculator. If you look above the sine key, right above that, it says sine with a little -1 in blue. Or in my calculator, it's blue. I think on the ones we use in class, it's yellow. So I'm going to hit my second button first to reach that second feature, then hit sine, and it puts in my inverse sign of, and I'm just going to enter that decimal, 0.9511. Now, I'll get something pretty close to 72. Since I rounded this number, this will be a little bit different. But there you go, 72.00. So it is 72 degrees. And so you can see that the calculator understands, and it is built into the program of the calculator to do these ratios and inverses of those angles, or of those ratios to get the angles. Okay, so here's a little note I want you to jot down. If we are given the angle measure, and we're looking for a side length, we use regular sine, regular cosine, regular tangent, like we did in the previous lesson. But if we are given the sides and we are looking for an angle measure, we use inverse sine, inverse cosine, or inverse tangent. And so it really means this. The inverse trig of the ratio, so the inverse sine, cosine, or tangent of the ratio equals the angle measure. So we're going to put that into practice with a couple examples. Now we're going to go back to the note packet. So we can use the inverse trig ratios to find angles that are missing. So in this case, we are missing this x value here, and again, we could call that a theta, but in this case, they give us the x. So this is my angle. I'm still going to write SOHCAHTOA up here, because I still need to figure out which inverse trig ratio to set this up as. And I'm going to show you kind of a longer way until we get used to doing some more of the shortcuts. So in this problem, we are given these two side lengths. You'll notice these are both the leg lengths, and then we're using this angle measure. This is my unknown angle, so that is the reference angle. This leg is the opposite leg. This leg is the adjacent leg. It's right next to that angle. Since I'm using opposite and adjacent, that means I use tangent. So I'm going to set up my tangent ratio like this. I'm going to say the tangent of x, because I don't know the angle measure, I'm putting an x in that place, equals opposite over adjacent, so 9/20. What that means then is to immediately go into the inverse tangent scenario. I'm just going to flip these around. I'm going to say the inverse tangent of this ratio then has to equal this angle measure, x. And that just tells me what to put in the calculator. That's not my final answer. I know I put a box around it, but that tells you what to enter into your calculator. So we're going to take the calculator and we're going to enter the inverse tangent of 9/20. And we can enter this without changing that to a decimal first. And I'll show you how. So we hit our second key and then tangent, and it brings up inverse tangent. And then I already have my parentheses open, so I can just do 9 divided by 20 to write that as a fraction. 9 divided by 20. And it writes it as a fraction. Close that off, hit enter, and we get that our angle measure of x here is about 24 degrees. And I do want to put my degree symbol because we did find an angle measure. Okay? So let's try another one. We are given this x value here as your angle measure.
Teachers at this time.
Excuse that interruption, sorry. This is our angle measure. We are using SOHCAHTOA again, but we need to identify what these sides are to know which ratio to use. This leg, because it's part of the right angle, this leg is right next to the angle measure, so that is your adjacent leg. And then this side is actually opposite the 90-degree angle, so it's the hypotenuse. Since I'm using adjacent and hypotenuse here, I need the cosine ratio. So I'm going to say the cosine, sorry, wrong letter, the cosine of x equals adjacent over hypotenuse, or 17 over 32. And so then to find x, we're going to go backwards and rewrite this with the inverse cosine. Inverse cosine, cosine negative 1, of that ratio, 17 over 32, equals x. And that's what I enter in the calculator. Second, then cosine. Then enter your 17 divided by 32. Hit enter, and you get that this is approximately 58 degrees. This would round to a 58, so x is about 58 degrees. Okay? And so that kind of gives you some examples of how to use inverse trigonometry to find missing angles. All right, and so we're going to skip over these. If you want to try these before coming to class, that'd be some extra practice. But we're going to go back to that blank sheet of paper. You should be able to have room either on the back or a new sheet. And we're going to do another part of this lesson on that paper. You'll notice that I referred to this lesson as inverse trigonometry, which we've covered. And then I also said we're calling this, or talking about solving triangles. So I'm going to explain what that means real quickly, and we'll talk more about this in class. Okay. Solving a triangle means to find all missing angle and side measures. Okay, find all the missing angle and side measures. So we're going to do one example here of how to solve a triangle. We're going to start with some given information, and we're going to find all the pieces that are missing. All right, so in this example, if I give you this information, this is one kind of example for solving a triangle. I've only given you really 3 pieces of information. One is that it is a right triangle. You will always be given that piece that we have a right angle. Then I've given you one side here that is 4, and another side, or sorry, and an angle here of 55 degrees. This means there are still 3 pieces of information I don't have. I need to know this side length, let's call that x. I need to know this side length, let's call it y. And I need to know this angle measure, let's call that z. Those are the 3 things I need to know. X and y are both sides. Z is an angle measure. Now, 2 of these pieces of information are alike. They're both sides. We're going to find those kind of the same way. But this other third piece is an angle measure. We're going to find that differently. When I am given one angle measure, finding the other acute angle measure is very, very simple, because you need to remember that all 3 angles of a triangle add up to 90 degrees. Or, I'm sorry, 180 degrees. 90 plus 55 plus z has to equal 180. Well, that means I just have to add those and subtract from 180, and I should get 35 degrees. So z is 35 degrees. There's one of those pieces of information. But we're not done. To solve the triangle means to find everything that's missing. So we're going to pick one of the other 2 values to start with. You don't have to try and find them both at the same time. We're just going to choose one. In this case, it really doesn't matter which one we choose. I'm going to choose to find y first. Okay? Y is the hypotenuse of this triangle. We are given this 55 degree angle, even though I know this is a 35 degree angle now. I'm still going to go back to the original. That given angle measure determines that this leg of 4 is the opposite leg, and I'm looking for this y value hypotenuse, so I'm using those 2 first. That means I'm going to use sine. Remember, from SOHCAHTOA, the O and the H go with sine. So I'm going to say the sine of 55 equals this opposite leg 4 over the hypotenuse y. So to solve this for y, we have the angle, we're looking for a missing side, so that means I'm going to use regular sine, cosine, and tangent. In this case, regular sine, no inverses here. But I have to solve this as an equation like we did in the last lesson. When the variable's on the bottom, remember I told you to turn this into a proportion so we can cross multiply. Y times sine of 55 we write out on the left. and then 1 times 4 is just 4 on the right. Now we divide by the sine of 55. And that's what we will enter in the calculator to find the value of y.